students. The last video we have discussed about mass and weight. So mass is the quantity of substance present in a body is called as mass, and product of mass and gravitational force is called as weight. In continuation to that, I have given density and relative density explanation in this video. So let's take first density. Density of a substance is the mass per unit volume. Mass, how much matter consisting in a body is called as mass. That mass per unit volume gives you the density of a substance. So density is given by the formula density equals mass by volume. It is indicated by the Greek letter rho or HO. Rho is the indication of density. It is a Greek letter. Greek letter rho equals mass by volume. Mass, as we know the definition, mass is the quantity of substance present in a body divided by the volume of substance. Volume is how much area it covers, and multiplied with thickness gives you the volume. Mass by volume is the formula to calculate density. It is indicated by the Greek letter rho. There are three systems of units, as we know: CGS, MKS and FPS. Unit of density in CGS is gram per centimeter cube, in MKS is kg per meter cube, and in FPS it is pounds per feet cube. So these are the three types of systems. So we can observe the density of different materials by the simple example. Let's take 1 kg of solid, any metal, 1 kg of any metal, and also 1 kg of cotton. You may observe the volume of metal is small, the size of metal is small as compared to the volume of cotton, if though there are both the masses are same. That means the molecules in the metal are thickly packed. They are very thickly packed, and there is very less gap between the molecules of iron. But in case of cotton, the molecules are spacely packed. There are spaces between the molecules, hence the size or the volume of cotton will be more. That means the density of thickly packed molecules is more, and density of spacely packed molecules is less. So in this diagram I am giving you a simple picture of how the molecules are arranged in case of the thick and lightly packed substances. So there are density of matter in this diagram. The gas, you may observe in the first diagram, it is gas. In gas, the molecules, you may observe the molecules are rarely packed. They are having gap between the molecules. The molecules are having gap between them in the gas. So density of gas is less. So coming to the liquid, there are gaps in the molecules of liquid also, but not as much as in the gas. That means the liquid molecules are moderately gapped. There is a small gap between the molecules of liquid. Coming to the solid, you may observe here the molecules are thickly packed. There is a very small gap between the molecules. Hence, the molecules are thickly packed in solid. They are high density materials. Liquids molecules are moderately packed in dense. They are moderate molecules. The density is moderately less. But compared to gas, the coming to gas, the molecules are very rarely packed. That means there is a more gap between the molecules, hence they are having less density. So in this way we can identify the material by the density. If density is more, we can call as dense materials. If density is moderate, they can be called as moderate dense materials. If density is very low, they are low dense materials. So gas is a low dense material, liquid is a moderate dense material, and solid is a high dense material. So in this way we can distribute or categorize the molecule substances like gas, liquid, and solid. They are low density, medium density, and high density substances. Next, coming to relative density. Before coming to relative density, we can explain easily how the materials will pack on one another according to the density. You may observe in the diagram that the highest density material, that is in this diagram, it is a density tower. It is called as density tower. You may observe honey is having highest density, that is 1.36, compared to caro syrup, that is caro syrup density is less than honey, that is 1.33. That means this syrup float on honey, it doesn't penetrate through the honey because its density is low. Next, coming to the dish soap, its density is 1.03. It floats on 1.33 density caro syrup. Next, coming to water, it is 1. Water density is always 1 and it floats above the dishwash powder. Next, coming to veggie oil, that is oil of vegetables, it is almost 0.91. It floats above water because its density is low. Next, coming to one more, that is rubbing alcohol, its density is 0.87. It floats above veggie oil. So in this way, the density, if the density is less, it floats on high density liquid. You may observe here all the liquids are placing one on another. You may observe the high density is in the lower part and low density is in the upper part. That means low density oil floats on high density oil. So this is the easiest way to understand how the low density material acts with high density material. This tower, density tower, will be useful to explain the density of different types of oil, liquid, or water anywhere. So liquid can be arranged in ascending, descending order of their density in this density tower. Next, coming to relative density. So relative density is the relation between two densities. One is substance, another is water. So relative density is relation between two densities. One is density of substance and density of water. So density of the water should be taken at its temperature 4 degrees centigrade. That is the important one, because at that 4 degrees centigrade the density of water will be maximum. So RD is also called as relative density or specific gravity, because we may compare the density of any substance with water or other reference substances. Hence RD is also called as specific gravity. So as the RD is the ratio between density of substance to density of water at 4 degrees centigrade. It has no unit. RD, relative density or specific gravity, you may call it as, it has no unit. So I have given a simple diagram here how the RD works. You may observe here the relative density of steel is 7.8, which is much higher than water, hence it sinks in the water. In the first diagram, this is a steel round ball, which is having a relative density of 7.8. So relative density of steel ball is much higher than water, hence the steel ball sink into the water. It is sinking into the water. Next, coming to the second diagram, the relative density of wood, a round ball of wood, is 0.5. The relative density of water is 1. As the relative density of wood is less than water, it floats on above the water surface. So in this way, we can understand what is density and relative density easily. Both the density and relative density are related. Density is the mass per unit volume and relative density is density of substance per density of water at 4 degrees centigrade. So this is about density and relative density. In next videos I am going to give you some simple problems of finding RD and density of different materials. So thank you, thanks for watching.